Now let us see the partial release option as well. Let us go to General tab and go to Specification sub tab. Now click on beam. Here if we choose partial movement release, and all these check boxes will be active. How much partial movement release to apply in the columns or the beams entirely depends on the codal specifications that is followed in your country. So I suggest you to make some Google searches regarding the movement releases or the force releases that is accepted in your code. Here I'll just give an example of the movement release. So partial movement release, where you want to release the movement, I'll release the movement in all three directions, MPX, MPY and MPZ. Here 0 means full movement restraint, not release, it's restraint, and 1 for no movement restraint, which means that if the value is 0, it will restrain the entire movement, or there won't be any movement distribution, or it will transfer the entire movement that appears in that instructional member to the next member. We will release 30% of the movement, that is why I'll give 0.3, which means that if I give the factor of 0.3, suppose that if 10 kilonewton meter movement is induced here, in that case it will multiply that movement, that is 10 kilonewton meter, by 0.7 and transfer to the next member, and also 0.3 and also 0.3, and okay, and after that click on add. Now I will assign to all these columns. Okay, by pressing Ctrl I'll select the columns, and at the start position I will just assign them, yes, and also define. Okay, at the start position, if I just highlight over it, then this is my start position. Okay, now again go to analyze and click on run analysis, click on save, click on done. Okay, go to post processing and click on done, click on OK. Now let us see the movement in the Z direction, and let us see the values. Go to results, click on view value, click on beam results, and click on maximum, or just select the ends and click on annotate. You can see that earlier the value was 10 point something, now it's 7.991, which means that we have released certain movement. This is how you release the movement or the forces in STAAD Pro. We will see the beam offset command that is available in STAAD Pro. To explain the command, I will use the same example that I used in the previous video, just to save some time. Okay, to explain what this offset is, let me select this column, this beam. I'll just select these two and click on render option that is available here. Left click on it, and if I go to the closer view of this connection, then you can see how they have been connected. Okay, you can see that the beam has gone into the column up to half of its width, right, and the column is, and there is a small gap between the column and the beam portion over here. The column should have gone up to the top of the beam, but it hasn't gone. Okay, in reality what happens is that in the beam column junction, it doesn't happen like that is shown in the STAAD Pro. In reality what happens is, you get a column here from the ground, you get the column, and there is the beam like this. Okay, this will continue, this will also continue. Okay, when the beam just in STAAD Pro, the beam goes into half of this column, right? If it goes like this, here also it goes half into the column, the span of the beam increases from here to here. Due to the increase in the span, the moment value also increase. Due to the increase in moment value, the reinforcement value also increase. To economize our section and to tell STAAD Pro what the real scenario at the site is, what we do is that we tell STAAD Pro to take the beam from face of the column from here to here. By doing this, we decrease the span of this beam and thus decrease the moment and thus decrease the reinforcement on it. Similarly, we can offset the column so that it just goes to the top of the beam. Okay, I'll just show you how to offset the beam, and using the same concept you can offset the columns as well. We're gonna tell STAAD Pro, we'll tell that we know in this case our column is, right now the connection is like this, okay, this is the center of the column. The width of the column is 0.1 in our case. So we will tell the STAAD Pro to offset this face here, and also in this case we got the beam and we got the column like this, and this face at the face and this portion at the face of the column. To do this, the beam has to offset by half of the width of the column, that is 50 mm. Okay, because this entire width is 100 mm or 0.1 meters. Similarly, here we will go in the negative x direction of 50 mm by 50 mm. Okay, all right, so as x is positive in this direction, so this value is positive and this value is negative. Now let us tell STAAD Pro to do that. For that, we will first define the offset. Go to beam and click on offset, and at the start location, which means that this location is our start location, we will offset in the positive x direction of 0.05 mm by 0.05 meter, and click on add. Again, go to beam, go to offset, and the location is end, and the offset value is minus 0.05, and click on add. After that, select the beam, okay, not this one, select this one, and okay, so you can choose end first and make sure that assign to the selected beams is selected, and click on assign and click on yes. Again, select start, check this option, click on assign, click on yes. Now let us see the 3D rendered view of this joint. Select the column as well, go to 3D rendered view. Now you can see that the beam is at the face of the column. For your practice, now take the column up to the top of this beam. You can use the same method that I used for the beam. Now we will analyze the structure. Go to analyze and click on run analysis and save it. Go to post processing mode and click on done. Click on OK here. Now let us see the MZ movement. Now if you zoom in and you see that your movement value is now displayed slightly away from the beam column junction. Similarly, if you see here, in this case, however, the movement diagram has been displayed from the beam column junction. Now you can see that this beam is on more realistic approach. Okay, I did offset here as well, but there is only the secondary beam, and you need not to offset in the secondary beam position. You have to offset the secondary beam here, not the main beam. I made a mistake here, but I just wanted to convey a message, and I think I'm pretty much successful on that. Okay, depends on how well you can grasp it and how well I can explain it. It's a two-way process, learning and teaching. Okay, it's not the one way. If I see the movement value, go to results and click on view value and go to beam results and click on ends and click on annotate. And you can see that at this position the moment value is, if I just use the dynamic zoom here of this portion only, you can see that this value is 19.556 kilonewton. I think before the moment release it was something like 21 kilonewton meter. I'm not sure. You can see the how by decreasing 50 mm the moment value has decreased. And in real columns, if you decrease it by 200 or 300 mm, in that case there will be much more decrease in the moment values. This is how the offset command is helpful. Just explain other tabs that were available there. They will not come much handy, but just for your information, go to specification tab and go to beam button. And over here we talked about the release, we talked about the offset. Now let us see property reduction factor. If you want to reduce cross-sectional area by certain factor or torsion or movement, you can use this tab. Next one is the cable. You just define the structural member, and if you want that structural member to behave as a cable, you can use this tab. Similarly for the truss, we know that in the truss there is no movement at the joint and there is only tension and the compression force. If you have defined any truss in your structure, then you have to tell ETABS that this member is my truss member. And if you just do the same process that you did for release or offset, how? Just click on truss, click on add. After that, select your truss member and click on this member truss and click on assign and click on yes. Click on yes. And if you see that there won't be movement at these two positions, for that go to analyze and click on run analysis and click on save. Okay, I might be going a bit faster, but these things we have done over and over again. Click on done, go to post processing window, click on OK. Now if we see the movement value, click on MZ, you can see that there is no movement in this member, which means that this member is now acting like a truss member. Same thing you can do with the real truss members. Okay, you just have to define the truss members, you just have to select all those truss members, and you just have to assign the truss specification to those members. Again, I am in the specification tab, please go to it, and after that click on beam. And next one is the compression. If you want your member to just take the compression force and not any other force, you can use this tab. And next is the tension. If you want your member to just take the tension force, you can use this tab. And next is the inactive. If you want your certain structural members to be inactive during the analysis process, you can use this tab. If you do that, then the movement or the forces of that structural member will not get transferred to the other members. Similarly, we got fireproofing, where you can define the fireproofing property of your member, and also we got the imperfection member, where you can define the drift and the cambers. In this tab, select the camber radio button. On doing so, the related parameters will be displayed in this tab. Next, specify the parameters for the camber and choose the add button to add the camber specification. Next, select the added specification and assign to the required members. Similarly, you can define the drift as well. Click on close. This is how you offset your members. Hello friends, welcome to the new section. In this section, we will learn how to model a building. So we will use a simple residential building that you can see on your screen. And in the next section, we will learn how to apply various kinds of load. And after that, we will learn how to analyze the design, and we will also learn how to detail the various structural components of a building. Before moving into the course, I would like to first explain few things and tell you where this software comes into play, the STAAD Pro software that we are practicing. Okay, in a building design, in the process of designing a building, where exactly this step or this software comes into play. Okay, let me explain you this thing. So let us assume that there is this guy. Okay, this guy, let us call him client. Okay, and he got money and he wants to build a house, or any structure, maybe a shopping mall, or anything. He wants to invest the money. So what he will do is that he will first go to a consultant. So he will go to a consultant. Okay, so this consultant will have, so it's a office. The consultant will have architects. He will have structural designers. Okay, and he will have quantity estimators. He will have draft person. So what the draft person will do, I'll tell you in a while. And he will have other people, like people who prepare bidding documents, bidding and contract, let me say that, contract documents. So he will have all those things. Okay, and the consultant will also give you advice, whether to increase the size of the room or decrease the size of the room. Okay, so they will do that, and based on the concept of the client and suggestion of the consultant, they will first prepare the architectural drawings. Okay, so the architects will prepare the architectural drawings. So how the architectural drawing looks like, so I'll show you that in a while. So the architectural drawing basically will tell you what the structure is all about. Okay, and how it's gonna look, and what are the various components of that structure. So once the architectural drawings are prepared, the drawings are forwarded to the structural designer. So structural designer is a civil engineer that has mastered in structural engineering. Structural designer, what he will do, he will use those drawings, and using the software like STAAD Pro, or you can say ETABS. It's a very famous software. I got SAP 2000. So he will use any of the software based on what he is expert of, and he will model that structure, house, let us say that house he will model, and he will analyze and design. And once he has done designing, so the software will give him reinforcement of beam and column, and using a manual method or Excel sheets that he has already got, he will design the slab and footings and staircase as well. All these designs that he has done, so he will just make a rough sketch. Okay, on a paper or anywhere, he will just make a rough sketch of the reinforcement. Okay, and once he has done that, he will give those rough sketch to the draft person over here. So the draft person, what he will do, he will make the structural drawings based on the rough sketch given by the structural designer. This is where our software comes into play. So this is the step where our software is used. Now let me explain furthermore what happens then. Okay, so for that I'll use another color. Okay, after that, so they have prepared architectural drawings, they have prepared structural drawings, so they will prepare electrical drawings as well. So the electrical engineer or any specialist will do that, and they will prepare the sanitary drawings. So okay, and based on all these drawings, what they're gonna do, so if they have got any AC or any other things, so they will also prepare those drawings. And what they will do is that now, based on all these drawings, so they will estimate the quantities of the various components. For example, in structural drawing, so in a structural drawing, they will get the quantity of rebars, or you can say the steel bars that are used. So they will get that information, and from architectural drawing, they will get all the information. Much of the information is obtained from the architectural drawing, such as the size of the the amount of bricks that will be used on that structure, and amount of concrete that will be used. So this also can be obtained from the structural drawing as well. All these things, they will get the quantity of everything that will be used in that building. After that, what they will do, they got the quantity, so they will put the rate of each quantity, and based on that they will get the total amount or the total cost of construction. So they will get it. Once they will get the total cost of construction, they will tell the client, so they will tell the client that your structure will be prepared in this much of money, and he needs to arrange that money. So after that, what they're gonna do is that, so they will prepare the contract documents and the bidding document. So what a bidding document is, now we got a project to do here. So we got a project to do here. So here we got a house to build, and what now the consultant and the client combinedly will do is that, so they will call the contractors. So they will call contractor 1, contractor 2, contractor 3 to build that house. And the consultant, what he will do, he will give the contract document and the bidding document. So bidding document will contain all the information about all the quantities that will be used in that project, and the consultant will give those information to all these contractors, and the contractors will fill this rate. Suppose if it's a brickwork, the rate of the brickwork that is filled by the contractor 1 might be $100, and by contractor 2 it might be $110, and contractor 3 might be $90. Okay, so they will fill all these things, and they will finally give the final price by which they can do that project, and they will submit it back to the consultant. Okay, so they will submit it back to the consultant, and once they have submitted, the consultant will award that contract to the lowest bidder or the person that has quoted the lowest amount. So that is how the bidding is done. And once the contract is awarded, the contractor will do the work and finally give the handover to the client. So this is how a project is done. And also there are other micro things that I have not explained here, how the supervision is done, and how the handover and all those stuffs are done, and how the contract is actually carried out. Keeping this short, so I just wanted to explain how a project is carried out, so it will be helpful for the freshers that have not been to the site or any office. Okay, so this is how everything is done. In the next video we will see the architectural drawing, and we will know what information we have to extract from the architectural drawing.